This is 7th grade 7.1.1, and it's titled, What is the Relationship? Distance, Rate, and Time. In this course, you've looked at several relationships between two sets of information and investigated how one piece of information can or cannot be found from the other. To continue your investigation of proportional relationships from Chapter 4, you will look at the mathematical relationship between distance, rate, and time. Later, in the final section of the chapter, you will identify proportional relationships and use your understanding of proportionality to solve problems. So 7-1 says George stood on the train platform and waved goodbye to his sister as she left for summer camp. Later, as he was getting in his car to drive home, he saw a light flashing inside the train station and heard an announcement that his sister's train had malfunctioned and was stuck on the tracks. George had a map of the train's route and decided to drive to where the train was stuck and pick up his sister. How can he figure out where the train is? What information would help him figure that out? So this is 7-1. So the information that I thought of was, well, if he knew how fast the train was going, so if he knew the speed of the train, and he knew the amount of time that passed, so say like half hour passed, you could figure out the distance that she traveled, because the speed and the time passed relate to each other. So that's what I figured out. If you have another idea, you can put that on your paper. But that's really all you had to do for 7-1, is to just, how can you figure out where the train is? What information would help him to figure it out? Okay. 7, and this is kind of just getting us into the whole concept of distance, rate, and time. So distance, rate is just like the speed, and time is, of course, just time. 7-2. So 7-2 required us to do an activity in class with like movable toys on like a track, but since we're not together, I have to revise this problem for you guys. So for 7-2, it wanted us to predict how far a car, train, or plane had gone, and it would be helpful to know something about how fast it was going and how long it had been moving. So it wanted us to take like a wind-up car and like a piece of paper, and it said to put the paper on the floor, draw a starting line, place the toy on the edge of the paper facing the starting line, and you were going to time how long it took to get to certain like spots on the paper. So we can't do that. If you want to try it at home, you can if you have something that works. But for part A and B, we have to skip because we don't have the means to do that right now over the computer. So for part C, it gave me a sample of data that we can use to finish the problem. So we're going to pretend like this was a team in class that had this table. And the table looks like this, and I also posted it to Google Classroom under this assignment. So it looks like this, time and distance, and it was 5 and 8, 10 and 15, and 15 and 23, and the time is in seconds, and the distance is in centimeters, I believe. So it says, obtain a resource page, and the resource page has, let me see, I think it has a graph on it, but we're going to draw our own graph. Yeah, it has a graph on it to show you how to draw it. So let's see, work with your team to organize your data into a table and graph it. So here's our table, so you write that down. Now we're going to do our graph for the same problem C. So let's see what the graph, I'm going to start it like this. And then the graph from the resource page shows the time on the bottom. So that's the time, and that's by fives, 5, 10, 15, 20, 25. And then this is the distance in centimeters. And I think I went by fives as well. Yeah, 5, 10, 15, 20, 25. I'm just gonna stop there. Okay, so now I'm gonna graph it using my data. So this is gonna be our X value and that's our Y. So we're gonna start on the X axis at 5, and then we're gonna go to the Y up 8. So we're gonna go up 8 and put a dot. That's about 8. Then we're gonna do the next one, which is 10, 15. So over 10 and then up 15. And the last one is 15, 23. So over 15, up 23. About there. So there is our graph. And it says, think about the following questions. And the little I says, where does your graph begin? Should your graph stop? So I know that my graph has to begin at 0, 0, because if the time of the seconds is 0, that means it went 0 centimeters. So that means it starts at 0, 0, the origin, and then it goes up there. So that's where it starts, 0, 0. And then it says, should your graph stop? I said it should stop when it reaches the end of the paper. And then it says, would it make sense to continue your graph to show how your toy would travel if you were to continue measuring for time? So yeah, it would make sense to me, because if we were going to keep going, we could just continue the graph and continue our table. So I put yes, that it would make sense to continue the graph. That's the little I don't know what to call those things. The little double I says, how far would you expect your toy to have traveled after 7 seconds have passed? After 2.3 seconds, does it make sense to connect the points? So I expected the toy, and I had to do some calculations to figure that out. So what you want to do when you're calculating, I tried to find the unit rate, because the unit rate is what you multiply this by to get that number, and this number to get that number to get that number, and it's going to be the same one every time. So to find the unit rate, you take this Y value, which is 8, and you divide it by the X value, which is 5. And you could do that for this one and this one and this one and this one, but I just chose 8 and 5. So if you divide 8 divided by 5, I forgot what I got in a decimal, but it would be 8/5, or what is that, 1 and 5 into 8 is 1 and 3/5. So that means that 1 and 3/5 is our unit rate. So you're going to times 1 and 3/5 by 5 to get that, by that to get that, by that to that, every single time. 1 and 3/5, 1 and 3/5, 1 and 3/5. So in order to find 7, because they want us to find 7 now, so if we added 7 in here for the time, we need to multiply that 7 by 1 and 3/5 to get our answer here for distance. So 7 times 1 and 3/5. I didn't do a fraction form, I did decimal, but I'll do the fraction form right here. 7 over 1 times 8 over 5, just 56 over 5. And if you put that in decimal form, it's about 11.2. And to do that, you just divide 56 divided by 5 in a calculator, and I got 11.2 for 7 seconds. So same thing if the next says, what about after 2.3 seconds? Then 2.3, which would be up here, but I'll do it right down here. Same thing, multiply it by 1 and 3/5, and you get about 3.68 centimeters. And then it says, does it make sense to connect the points on the graph? And I said, yes, it does, And it says why or why not. And I said, it makes sense to connect these points because the toy is going continuously. It's just going the whole time. It's not stopping and starting again. It's just going consistently a distance the whole time. And that is 7-2. For 7-3, it is wanting us to figure out the unit rate, which I already did for this problem. And our unit rate we figured out was 8/5 or 1 3/5. If you want to put it in decimal form, that's 1.6. And that means 1.6 centimeters per 1 second. That's what that dash means. It means per. So for every 1.6 centimeters, 1 second goes by. And it says, how can you see this in your table? Well, you can see it in the table by dividing this by this. Any y with the x on the other side, if you divide that y by that x, you will get the unit rate. And if to double check it's the same for all of them, you can do another one, but they're all 1 3/5 or 1.6 unit rate. And then you can see it on the graph, and I erased my graph already, but we could see it on the graph by looking at the steepness of the line, the 1.6. You could go, if you wanted to find 1 second, you would go to 1 second on the y and see about where it was on the x, and it would be at about in between 1 and 2, about halfway between 1 and 2. Okay, so that's 7-3. Wanted us to find the unit rate, and 7-4 says, how can you use the answer to 7-3 to write an equation relating the time the car has been moving to the distance it traveled? I'm going to erase this. I'm going to put 7-4 here. So I just did what I did in the table. I took the y value, so it was time and distance, and we had like 5 and 8 here. So all I did was I put this number over there, so that's the distance divided by time equals the speed. And the book actually wants you to represent it with the D being on the equal sign, the only side of the equal sign, so it's actually D equals R times T. And I'm going to put rate instead of speed. But rate is just the same thing as saying speed. So if you plug in the rate times time, you'll get distance. If you take distance divided by time, you'll get the rate. They're both related equations. We are going to focus on this one, I'm pretty sure, because that's kind of the universal distance DRT equation. Okay, 7-5. I'm going to erase this one now. 7-5 says, if your toy were twice as fast, how far would it travel each second? How would you use, or how would you see this in the table? How would you see it on the graph? Again, be prepared to explain. Okay, so if our toy were twice as fast, we need to figure out, well, our distance rate that we know of is 1.6 centimeters per second. So if it was twice as fast, I want to multiply it by 2, and I got 3.2 centimeters per second as the unit rate if it was twice as fast. So how would you see that in the table? How would you see it on the graph? Well, in the table, these would change to, say you had, the time was 1 second, the distance is 3.2. The next one would be like 2 seconds, and that would be 6.4. No, what am I doing? So yes, it would be twice as large each time. So for every second, it would get twice as large. And our graph, it says, what would it look like on the graph? It would look a lot steeper than our previous graph. Our previous graph went kind of like that. This graph is going a lot steeper. Okay, 7.6. If your toy travels at a constant speed, then the distance your toy has traveled and the time it has taken are related to each other proportionally. In a proportional relationship, two quantities are related by a constant of proportionality, or a constant multiplier. We're going to write constant of proportionality because we did talk about that in a previous lesson during the year. And that was just the multiplier that we used, or the unit rate that you multiply each value by to get the y value. For your toy, the constant of proportion is called the rate. In this case, it's also the speed. So rate and speed are interchangeable. Where else in this course have you seen them? Related by a constant multiplier. So I was thinking back to when we did finding the cost of things per pound. So say you could buy 5 apples for like 10 pounds, and then it would say how much would it cost if you bought 10 apples. So that was another way of us learning proportions and proportionalities and relating a unit rate to those things. So you write down what you think for 7.6. Where else have we seen these unit rates and the constant multiplier in our course? Okay, the last thing we're doing is I don't even think there's a learning log. Nope, there's no learning log, but I did want to review proportional relationships. And I do want you to write it down because it's important to know these characteristics of proportions. So we know that a proportional relationship has a constant multiplier between two quantities, also known as the unit rate. And in a table, values can be multiplied by the unit rate. In a graph, the steepness of the line shows the unit rate, or the multiplier. And in an equation, you're going to multiply the independent variable, and the independent variable is the thing that you're not changing. Rate to get, sorry, my writing's getting weird, dependent variable. So in our problem, the independent variable was the time, because the time is going to pass no matter what. But it depended on the distance it goes depended on the time. So that means that we multiplied whatever the time was, like 1 second times something, to get the distance. And that is the end of 7.1.1, and I'll see you in the next one.